All right, hey guys. So we're going to continue with digital painting techniques and applications. Hopefully you're getting a good handle on mark making techniques and using your brushes and going about blending your pigments. And the thing that I want to talk about in this video is I want to go over what's called linear perspective. So perspective is one of the most important ways that we can convey a realistic sense of depth and space in our images. And whether you're doing traditional paintings or digital paintings, having a strong understanding of linear perspective can really help take your painting to that next level, right? With realistic depictions of space, right? So some of you have probably already gone over perspective before in the past. If you've ever taken a drawing class, I'm sure you've gotten a handle on perspective. For those of you that this might be new, it can be a little overwhelming because there's a lot of little rules and things that you need to adhere by. But in the end, it's pretty straightforward as long as you understand what you're doing with your vanishing points and your diagonals. So I'm going to go over 1, 2, and 3-point perspective. It's not my expectation that anybody will be doing any 3-point perspective images. You're more than welcome to challenge yourself to those, but I think having a great understanding of 1 and 2-point perspective is really gonna help you guys out a bit. So 1-point perspective, and again, this is probably recap for some of you, but hopefully some of you might find this new and interesting. So with 1-point perspective, we're going to break down a few things that are essential here. So you always want to establish what's called your horizon line. And your horizon line is basically establishing where your head, where your eye level is in that space. So this is our horizon line. And in a 1-point perspective image, there's only one vanishing point. And that vanishing point will always be on the horizon line. Vanishing points are never not on a horizon line, okay? So let's say we're now going to just draw an object in space. So let's say we're going to draw this cube, right? We're going to draw a 3-dimensional cube. So we'll start with that square, and then all of my diagonals are going to go to that vanishing point. And the thing to note here about 1-point perspective is that all of your vertical lines will be parallel to each other. So here we have our parallel lines from that cube, okay? All of your horizontal lines are parallel to each other. And here are our horizontal lines from that cube. And being that is the case, that means all of your horizontals and verticals will always be perpendicular to each other. Okay, aside from your horizontals and your verticals, the only thing left are your orthogonal, or what are called your diagonal lines. So all of your diagonals must go to the vanishing point, right? And again, the horizon line is your eye level relative to the space. So usually if you're doing a drawing or a digital painting or whatnot, you have to first determine where that space is. If you're really low on the ground, and you're possibly looking up, you'll want that horizon line very low. If you're elevated in space and up high, then you'll want to put that vanishing point up high, and that will really give the viewer a sense of where they are in that space, right? And like I said, the vanishing point is always on the horizon line, and there's, 1-point perspective is just one way of doing perspective, but there's 2-point and 3-point, and you could have 10-point, 20-point, 50-point, right? The vanishing points are all relative to how the angles and how the objects are set up in space. So a 1-point perspective is great if the objects that are facing you are essentially perpendicular to you. If you're seeing one whole side of the face of that square and it's not angled at like a 45 or anything, then 1-point perspective is great. But if you're in a 1-point perspective environment, say in a hallway, and there are objects like tables and chairs and boxes, if each one is tilted and skewed in a different angle, then those objects are going to have their own set of vanishing points that are independent from the 1-point perspective of the hallway. I know that sounds confusing here, but I think you'll get a better handle on it as we go through these other perspective methods. So I'll just show you some examples. So here's some objects floating in space, and you can see that these are the vanishing line, the diagonals are all going to that same vanishing point, and they've kind of extended them off those shapes there. So it's just showing you an imaginary space, but we can see how 1-point perspective works. And I'll go over some photographs here that can easily demonstrate 1-point perspective. So if we look at this image here, we can overlay radiating lines that are coming from that vanishing point, and we can see that all of those diagonals are moving towards that vanishing point. All of these vertical columns are parallel to each other, right? Railroad tracks here, this is a good example of one-point perspective. If we establish, right, the horizon line, which is kind of right up on that, you know, where the train tracks meet, we can put in our overlay, and then we can see, right, we can see the vertical pieces, right, these posts. These are all parallel to each other. All of these horizontal tracks are all parallel to each other, and the diagonals are all going to that vanishing point. Okay. So here's a drawing that's set up in one-point perspective, and it's much easier to see when I overlay things, but hopefully you get a sense that there is a mathematical structure to these images, right? Especially one-point perspective. It's really easy to see a one-point perspective if you know what you're looking for. Okay? So let's move on to two-point perspective. So just as the name implies, instead of one vanishing point, there are now two vanishing points. So think about your horizon line, where that is in space. And I'm going to put our two vanishing points on the paper, but most often you would find that usually one or both may be off of the paper, and I'll talk a little bit more about this as I get a bit further here. So let's say we want to draw that same cube, right, that we had from our one-point perspective example. Let's say we want to draw that cube again, but now instead of that face being directly perpendicular to us, now the cube is going to be at an angle. So I'm seeing two sides of the cube plus the top, right? So let's just establish this here. So I'm going to just begin to draw this, and the right side of the cube, which is what I'm working on now, the diagonals on the right side of the cube are going to go to the right vanishing point. Okay? And let's work on the left side here. So the left side of the cube is going to go to the left vanishing point, right? And notice my vertical lines there are parallel, right, and vertical. Okay, and then when it comes to the top of the cube, or rather the inside of the cube, if you think about if this was a box, for example, right, and I had to draw the rest of it, or the top, as I'm going to do now, right, the directions switch here. So the top or the inside of the cube, it'll reverse, and the back right line will go to the left vanishing point, and the back left line will go to the right vanishing point. Okay, and again, all vertical lines are parallel to each other. So here we have our three red verticals. And in a two-point perspective, there are no horizontal lines except if you have lines that are going directly on top or directly on your horizon line. So if we were to move that cube up in space, so the top of that cube reaches where where that horizon line is, then we would have a horizontal. But other than that, a two-point perspective does not have any horizontals outside of that horizon line. Okay? And then our diagonals must either go to the left or the right vanishing point. Okay? And yeah, there we go. Diagonals in green. Okay? So, like I was saying, in a two-point perspective drawing, right, here I just force both of the vanishing points on the paper, but oftentimes they would lie off the paper, even further to the left or right, and this would depend on the exact angle that you were looking at that object from. Okay? And I'll show some more examples here. So here's just another drawing of objects above and below the horizon line, right? Notice that objects below the horizon line, those diagonals are all moving upwards, right? They're all going up to the vanishing point. For the object that's above the horizon line, those diagonals are sloping downward, right, to the vanishing points. Okay? So we're looking at the exterior of this castle here. So looking at the object from the outside, right, we have the left side of that wall. And recall that the left side of that wall, the lines are going to go to the left vanishing point. Okay, and the right side of that wall, diagonals are going to go to the right vanishing point. And if we follow those lines out, we can see that we get a vanishing point. One is on the paper, the other one is slightly off the paper there. And I'm going to overlay those radiating lines out so you can just see how this all matches up. So if you can imagine taking that picture away, by putting those two sets of radiating lines down, I've essentially created a three-dimensional environment that's made up of this three-dimensional grid. So we can see how those diagonals are all fitting and flowing to the right vanishing points based on that, on that grid structure. Okay, let's do this again with the photograph so we can actually see how this applies, because one of the things that I found teaching perspective is that students find it really difficult to see this in real world environments, right? If you're standing in a hallway, right, your brain gets confused because you're trying to flatten that space and you're trying to look for the diagonals that are going to a vanishing point. But oftentimes they have a hard time seeing this, right? Because they're not used to seeing a three-dimensional space in this way that's compressing it into a two-dimensional image. So oftentimes photographs are kind of the best way to show this in practice, because they can really show you how these, how linear perspective works. So here we have the exterior of a building, and I'm going to show you how our lines are working. So I'm going to draw some lines from the top and through this building, but basically I'm looking for that left vanishing point there, right? So I see where they intersect, so I know that's going to be my vanishing point. And I know that all vanishing points must be on a horizon line. So what I can do from here is I can just draw a 90-degree dashed line to establish the horizon line. And if you remember that the horizon line is, you know, where your head is in space, or where this viewer was in space, or where the camera was in space, but basically eye level. And we can see that it makes sense. If I put a silhouette of a person in there at eye level, they look proportionate to the image, right? That looks like the size a person would be at an eye level, right? So let's do the right side now. I'm going to draw out these lines and continue them, just doing 2 on each side just so you can see. So that right vanishing point is a bit further away than the one on the left, right? But we can see they're both on the horizon line. And I'll put these radiating lines out again so you can see, right? You can see how all of those diagonals on the building all line up and they all go to the right vanishing points. Okay, so far we've just looked at exterior spaces, right? But now we're going to look at an interior. So imagine we're inside the box now. And remember, like I said, it flips now, it reverses. So the left side diagonals are going to go to the right side, and the right side are going to go to the left side. And I'll show you what I mean here. So here we have our left side of the cube. We're inside that cube. And the left side diagonals are going to go to the right vanishing point. So I used a diagonal from the wall and one of the diagonals on the ground, so to speak, but we would still consider that the left side. So we can see those lines intersect where that vanishing point would be. We know that vanishing points must be on a horizon line, so I can do another 90-degree line right from that vanishing point. And the same thing I did in the last image where I inserted a silhouette of a person. If I put a person in at eye level there, they look proportionate to the room, right? That tells me that we as the viewer are standing in this room at eye level. And let's do the other set of diagonals for the other vanishing point. Okay, so the right side wall, we have our diagonals that are coming this way, and we can see they intersect right on that horizon line. So there's my vanishing point there, and I'll take away these circles so we can get a better sense of that room, okay? So knowing when to flip your diagonals, right? So if you're on an exterior, the outside of an object, right? Recall the left side diagonals go to the left vanishing point, right side diagonals go to the right vanishing point. Unless you're doing a corner or the inside of a box, then it's the exact opposite. It'll flip. And as you start to do this, you'll see what I mean, and you'll be able to determine really quickly if you're doing it incorrectly, because the space just will not make visual sense. Okay, 3-point perspective now. So I don't generally have projects based around 3-point perspective. I just find it to be a bit more frustrating and a little bit more just something that, you know, people, if you're going to get interested in perspective, then you'll go on and you'll get into 3-point perspective. But for a lot of the things that we do, you don't necessarily have to go into it. It just depends, because this is a very particular instance where you would use 3-point perspective if you were really, really high or really, really low, right? So I'll show you what I mean by this. So I'm going to put my horizon line really high up on the paper, and I'm going to establish 3 vanishing points now. So I'll have vanishing point 1, 2, and 3, okay? So I'm going to draw that same cube that I did from the 2-point perspective example. So here's the right side of the cube, right? And now instead of, so I did a vertical line there because that vertical is directly in front of me, but the next vertical line is going to go to that vanishing point. We can see how it's angled down towards that bottom one. So now I'll continue the left side. Those diagonals go to the left vanishing point, and then that diagonal there is going to go down to the vanishing point on the bottom. Okay? And then same thing on the top, it's going to reverse. So that back left line is going to go to the right, and that back right line is going to go to the left. So now I have that box in 3-point perspective, which gives the illusion that I'm up high and I'm kind of looking down on it. So if you've ever been in a helicopter looking down on a cityscape, this is essentially the structure that you see, right? You see all those, what would be vertical lines if you were at eye level, are now going down to a vanishing point on the bottom. But other than that one vertical that's in front of you, there are no verticals that exist, right? It's just that one that's directly in front of you. All other verticals are going to go to that vanishing point, okay? Same thing with horizontals, like a 2-point perspective. There are no horizontal lines either. The only horizontals that exist are the ones that would be directly on that horizon line. But we don't have any here, but just demonstrating there. And then all of your diagonals are going to go to either the left, the right, or the top or that bottom vanishing point. And here I have these in green again, okay? So 3-point perspective is kind of a specialty technique. I mean, it's more for, like I said, if you were really high or really low. And just like 2-point perspective, usually most often your vanishing points would be off the paper. And in some instances, your vanishing points would be really, really far away. It just depends on how close you are to the object or how high or how low you are as well, okay? So I'll just go through a few more examples here. So here here's multiple objects in space. And if you just use your imagination here and just filled in kind of the information, you could see that this could resemble a cityscape, right? If you were up high looking down, right? And we call this bird's eye view, but we also call the alternative worm's eye view. So if you're really low to something or really high, right? These would be instances where 3-point perspective would be really valuable. And here's a really nice drawing of incredible detail, but this is a 3-point perspective, right? Really low to the ground. And if you guys play like first-person shooters or anything, and if you walk around an environment, you can really see this at play, right? As you're moving around and looking around the architecture, you can see these diagonals all change and flip and turn depending on where you're looking. So just the last image I'll show you here is just a photograph of 3-point perspective, and it's a little small because I just wanted to draw out some of the diagonals to show you that this does in fact work, right? So if I follow those diagonals up, I get a vanishing point up high like that. And then if I'm not quite there, but it's just right on that edge, if I take these diagonals out to the left, they meet right there. And then on the right side, right, they meet right there. I think it goes on a little bit more. I could have put a horizon line in a little bit lower, but I didn't want to shrink that image any longer. But this is just to demonstrate that 3-point perspective does in fact apply. And it's easiest to see when we're looking at photographs, but this is essentially how the world is structured around you, right? Learning how to compress this into 2-dimensional space, well, that's what we're doing here with our digital painting exercises, okay?